Hello. In this lecture, we are going to discuss about the principle of superposition. Uh, in the last lecture, we have discussed about some of the scalar and the vector quantities, and in the fourth lecture, we have discussed about the in the fourth lecture we have discussed that magnitude of the force between the two charges are equal to 1 by 4 pi epsilon naught q1 q2 by r square, and this is the magnitude. And because force is a vector quantity, then we have to specify the direction for it, and for this we are going to take the force as a vector quantity and solving these vector quantities superposition. And for this, let's suppose I take the origin here. This is the origin, and I mention the charge q1 at this point and at the distance r1 from this. And let's suppose I take the charge r2, charge q2 at the position r2 from the origin. And let for the simplicity, take the two charges as both of the charges of the same sign, positive. Let take as the positive. Then the force the force q2 apply on the q1 is in the direction of, then we simply say the line joining them, the q2 apply the force, the line joining them, the force I represent it by the r12, simply the force apply on the q1 charge due to the q2. And similarly, q1 also apply the force on the q2. This is we name as f21 charge. And what is the direction? We simply, this is the r12 vector. Simply we write this vector as the r12 vector, and this is the r2 vector, and this is the r1 vector. And then it come out to be, if you, this is nothing but if you find out the resultant between them, this come out to be r1, the r1 r2 plus, I can simply say that, because this is the vector, let me draw in another scale. This is the r2 vector, and this is the r12 vector. And because one vector is on the other as the on the head of it, then this is the resultant quantity r1 vector. Then if we write, this can be written as r1 vector is equal to r2 vector plus r12 vector. If we find out the r12 vector from it, we get the r1 vector minus r2 vector, and simply we can write it r1 vector minus r2 vector simply. And after that, and we can write the value, the f12 vector is 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught. And q1 q2 product of the charges, and the distance between them is magnitude of the r12 vector. And unit vector 1 r12. This is the force, uh, this is the force, and this is the unit vector in the direction of the force only. And similarly I can write the f21 vector. F21 vector is nothing but 1 by 4 pi epsilon naught q1 q2 by magnitude of the r12 vector, the square. I forgot to put the square here. And then minus of unit vector of 1 r12, because it is in the opposite direction. I simply take the unit vector of the negative, and then it become negative r12 vector. And simply we can see that from it, the magnitude r12 vector is equal to magnitude of the r21, because simply it means that the if the this is the third law. We can simply say that the third law of Newton, following the third law of Newton, simply it means that the q1 charge applying on the q2 is equal to the q1 applying on the q2, simply. And these are the laws of Newton, third law of Newton simply said that the every reaction has equal and opposite reaction. And from this, let's suppose we have the more than two charges. Let's suppose we have the many charges, and we want to find out the resultant from it. Then for this case we have to suppose that let's suppose the q1 charge at this point, and q2 at this point, and q3 at this point, and q4 at this point, q3, and then the force q1, the q1 charge apply the force, the line joining them. Let's suppose I take a vector. This is the force applying the force applied by the q1 charge on the q2 is f21 vector, and simply, and similarly the force due to the q1 on the q3 charge is f31 vector. And similarly, let's suppose the line joining them of the q2 and q3 are is force f on the q4 is f41 vector, simply. And we want to find out the resultant of these all the vectors, the charges in anywhere in the, let's suppose for the simplicity I take the one other also the charge. Let's suppose the q5 charge is here, and then the force is in this direction, f51. And let's suppose I take, first of all I take these two charges only, these two let us consider the q5 and the q2 are there only, and I am going to solve these forces and finding out the resultant. And in the, we know that any vector can be taken out in any plane, can be moved in this plane anywhere. Basically the magnitude and the direction should be remain the same. Let's suppose I put the vector f21 vector here, and the other f and I take the f 5 1 vector at this point. Let's suppose I take the vector f 5 1 vector here, and then we make a parallelogram. Then the parallelogram look like this. This is the again f21 vector, and this is the vector f51 vector, and this is the resultant of these. This is the resultant of these vectors, and this resultant, let's suppose I say that this is as f21 vector plus f51 vector. Yes, let's suppose I name it fr1 vector, and then again let's suppose I take the f3 vector. We have find out the resultant of the f1 vector and the f2 vector, and these two are remaining. Then again I take the resultant. Let's suppose I can take the resultant here. Let's suppose I can move the resultant here in this. Let's suppose this is the resultant fr1 vector in this direction, and f f31. Let's suppose I in same direction with the same magnitude. You can shift any vector in the any in this plane only. You can move out the vectors. Simply let's suppose this is the f31 vector, and then again I can find out the resultant of these two vectors, making the parallelogram again, and this is the fr1 vector, and again finding out the resultant. Let's suppose this is the resultant. This is the resultant. Again, this is the resultant. This resultant value is f r1 vector plus f31 vector, and is equal to, let's suppose I say that the fr2 vector. Similarly, I can take the third vector, and again taking the resultant of the blue resultant, and then again taking the this vector, and again simplifying the expression. We can, in this way we can find out the resultant. This is nothing but superposition principle, and I will write in mathematical way these expressions. uh, let's suppose the value of the f1 vector, we can write force on the charge f21. I write as f21 as 1 by 4 pi epsilon naught q1 q2 by r21 vector, and simply r21 vector, unit vector. This is the unit vector, and similarly I can write f31 vector, force on the charge q1 due to the charge q1, and I can make equation q1 q2 by r31 vector and r31 unit vector, and again f41 vector and 1 by 4 pi epsilon naught, and q1. Okay, sorry, for this I have to take the q3 and q1 q4 1 by r41 vector. Then the superposition principle say that you can add it all these forces by vectorly, that we have represented it in this way, and you can find out the resultant. Similarly, I can write the FR resultant vector is equal to F1 F21 vector F21 vector plus F31 vector and F41 vector, and similarly F51 vector. In similar way, you can write any number. Let's suppose you have the n charges, and I can put the 4 and 1 vector, and then I can simplify. Then I can put the summation sign. This is the nothing but summation sign, and I can make this as Fn1 vector and F1 vector simply, and n value is going from the 2 to n, and basically do not forget it. Let me take it as j value, and j value is going, because we can't take the 1, because any charge do not apply the forces on itself. So I take the j value starting from the 2 only, 2 3 4 5, and I can also write this equation as j is equal to 2 to n by putting the values of it, q1 qj, and in the denominator qj1 square, and then rj1 unit vector. rj1 unit vector. This is nothing but the superposition principle. Hello. Now we are going to discuss some questions related to the forces and finding the forces between the charges, and resolving the uh, vectors, and finding out their resultant. And for this, I have supposed the one problem. The problem is, let's suppose a equilateral triangle of side LLL, and the at the vertices of the A, B, C, I have put the charge Q, Q, Q of the same charges of the same magnitude, and we have to find out the force on the capital Q. It is at the median. It is in the at the median of the triangle, and simply we have to find out the force on capital Q due to these small charges uh, kept on the vertices of it. And for this, we are going to assume that let's suppose the Q charge uh, is apply the force in this direction, and I give the name for this force uh, is F1 vector, and in this force F2 vector, sorry, F2 vector, and the Q3 charge apply the force in this direction, and this is nothing but, okay, these are the equal in the magnitude, so I have to make the vectors equal, basically equal vectors. Let this is the F2 vector and this is the F3 vector. Symmetry, the resultant of F2 and F3 is in this direction, and I represent it by the some red color. Let's suppose this is the RF vector. Then we have to find out the magnitude of the RF vector, and because this is equilateral triangle, then the angle, total angle, this is 60 degree, and then total angle is 60 degree, and if it is median joining the median, then it is 30 degree. then we have to find out, basically we have to find out the distance between them, because we have to find out the magnitude between them. For this we have to find out, let suppose that this is the O point, and we have to find out the CO to find out the because we have to find out the force between them, then you have to know the distance between the two charges. And for this let's suppose the force, then F2, for the finding out the CO, then we have to use the because this is the L by 2, because it's the median. Median, it is the line passing through the median. Then L by 2, and by using cos cos 30 degree. Cos 30 degree is nothing but the base is L by 2, and hypotenuse that we have to find out, this is nothing but CO, and then CO come out to be L by 2, and under root 3 value go to the under root 3 value is under root 3 by 2, and then 2 will cancel out, and then CO value is come out to be L by under root 3, and then the force F2 becomes F2 vector magnitude is become then 1 by 4 pi epsilon naught Q2 capital Q, because in the middle we are taking the capital Q charge, and the distance between them is L under root 3 the whole square, and this is the magnitude basically. And the direction we have already shown, just taking the magnitude. And similarly the F3 vector magnitude is nothing but 1 by 4 pi epsilon naught Q, because Q2 is equal to Q only, because all the charges have the same magnitude, and basically I can replace it by Q and capital Q. This is also the length L by under root 3 the whole square, and this is the F1 and F2 magnitude, and the resultant come out to be in the direction of the vertices of the A, and then this also the Q remains. This Q also apply the force on the capital Q in this direction, and we are going to find out this also. Before that we have to find out the magnitude for the resultant vector, and for this we have already discussed in the last lecture how to find out the magnitude of the force of the resultant. It is nothing but under root F2 vector magnitude plus F3 vector magnitude, and plus 2 square, and then F2 vector. This is nothing but simply representing the magnitude, and cos theta. Cos theta is the angle between the two vectors, tail angle of the this angle the angle between the two tails, and simply then if we solve this expression, because F2 and F3 are equal in magnitude, then we simply say that these are equal. Then I put it as F, then other simplification, then F square plus F square plus 2F cos theta. Cos theta is interesting to find out. Then this is 30 degree, then 30 angle, then this angle becomes 120 degree, because the sum of the triangle is 180 degree. Then this is equal and opposite, and then it become the 120 degree only. then the cos theta is come out to be 120 degree. And if we simplify it, cos 120 degree is nothing but I can write cos 180 means 180 minus 60 degree. Then cos 180 degree, let me put the 2f1 square only, 2f f square plus 2f square, and then cos 120 degree, because in the second quadrant it come out to be cos 60 degree, and then it become negative because cos in the next second quadrant negative. Cos 60 degree come out to be 1 by 2, and then 2 will cancel out, and then minus square, then it come out to be f vector only, and then it resultant come out to be f vector only, simply f the magnitude. And then if we find out the force due to the q charge on this capital Q, then the force F1 I represent it by the F1 vector, and it is nothing but 1 by 4 pi epsilon naught, and Q, capital Q, and the length will remain the same that we have find out the CO length. And then basically then it is nothing but F, because one F resultant of the F in this direction, and the other is F vector is in this direction, and then they are equal in magnitude and opposite in direction, then they will cancel out, and the resultant resultant force on the all these charge configuration on the middle point capital Q is 0. And simply this problem.